Ladies and gentlemen, welcome to the Core of Everything. And today our guest is Dr. Kate Marvel. Kate is a associate research scientist at Columbia University and the NASA Goddard Institute for Space Studies. As always, please give us a follow on Instagram at CoPod, that's COE Pod, and Twitter, X at the CoPod, COE Pod. Enjoy the episode. And it seems that you have taken a not quite the linear path into academia. You started right with drama.
I did, yeah. So I wanted to be an actress. More specifically, I wanted to be a famous actress. I wanted to be a movie star, but that's a rough career path, especially when you're not talented. So that was a problem. And I don't know about you, but when I was a kid, I didn't want to be a scientist at all. Like, I thought science was boring. I thought science was useless. And more importantly, I thought science wasn't creative. And so I didn't want to be a person who wasn't creative. And then I took a class in college. I took Introduction to Astronomy, and I was like, oh my God, this is science. So I completely switched my major because I wanted to know more.
Wow. Where do you find the, because you went from drama and then you sort of went from Macbeth to then the theory of relativity. And you looked, your PhD was in the cosmological constant, right? And
It
Einstein.
was, yeah. And a problem that was unsolved at the time, still very much unsolved. Not sure how much progress has been made since I left. Um, and yeah, basically the problem was that there seems to be something that is not just expanding the universe, but accelerating its expansion. And this dark energy constitutes, 70 something percent of all of the matter and energy in the universe. And we have no idea what it is. We know that it's acting as kind of an anti-gravity, and we know it's not conventional matter or conventional energy, but we have no clue. And one suggestion is that it could be zero point energy. So quantum mechanics says that nothing is ever still. Everything is always sort of oscillating. You can never reach absolute zero because of the sort of intrinsic quantum weirdness of the world. And if you add up the zero point energy of everything in the universe, you get a number which should be, we think, accelerating the universe, but it's 120 orders of magnitude too big.
Whoa.
And so that is a problem. So the cosmological constant problem is what's accelerating the universe? Why isn't it the zero point energy? And how do we make it into something that's not zero but not large? And that's something that people have been thinking about for quite a while.
And I mean, I'm not really from a physics background. Are you trying to say the dark matter is the thing that's accelerating the universe? That's the
So
driver.
so dark matter is another thing that we don't understand. So dark matter is about a quarter of the universe. That is something which is not necessarily energy. It's matter. It's something that's matter. We don't think it's baryonic, which means we don't think it's made out of normal matter stuff: protons, neutrons, electrons. Do we have any idea what that is? No. So that's the 25% of the universe we don't really know. And the almost 75% of the universe, that's dark energy, we also don't know. We know that dark energy is not dark matter. So there's an incredible amount of we don't know in cosmology.
Yeah, I thought the sort of eternal inflation theories and all that sort of stuff was just based on the Big Bang and how it's just accelerating, still accelerating faster away because of the Big Bang.
Basically, the Big Bang happened, we think. And the universe is accelerating, or is moving out, is expanding following the Big Bang. But if there were only normal stuff in the universe, matter, it would be, the gravity of that matter would be slowly slowing down that expansion. And eventually the universe would end in kind of a reverse Big Bang, a big crunch. Not only is that not happening, but something is actually pushing the universe to make it accelerate faster and faster and faster. We have no idea what that is.
Maybe something stretching it either side of the universe and someone's pulling it away. Who knows?
Just two guys, yeah.
Having tug of war. Yeah. You went into sort of physics and that was at Cambridge. And I think you said before that it wasn't the most it wasn't the most lovely of times. There's like a sort of a supercilious nature, maybe kind of a pompous nature to physics. Is that quite right? Would you say?
I thought so. I did my undergrad at UC Berkeley, which was a fairly supportive, friendly place. And then going to grad school at Cambridge, um, you know, I Cambridge is a very strange place. They have high tables and dinners where everybody dresses like a giant bat. There's lawns that you can't walk on, which was just weird to me as a Californian. And there's a lot of standing on tradition there. I didn't love it. I didn't love the heavy. It was heavily male dominated, and I had no problem with men whatsoever, but it was dominated by the kind of men who were a little insecure, and wanted to prove that they were smarter than everybody else. That's, I think, one of the problems with theoretical physics is that people are aspiring to a theory of everything. People are aspiring to be Einstein or Feynman, like they're aspiring to be geniuses. And that's actually what I love about earth science, about trying to understand what's going on our planet, is that everybody knows that there are limits to our expertise, right? Like I know that if I want to know what the climate was like 50 million years ago, I have to go and find a geologist. I have to go and talk to climate modelers. I have to go and talk to oceanographers. And that to me is one of the most beautiful things about earth science as a field and climate science in general, is the fact that it kind of forces this humility on you.
Yeah, for sure. Do you think it's gotten better at places like Cambridge? And
I don't know. I mean, I think it's gotten better in general. Cambridge, I don't know. Cambridge is still to a certain extent trapped in the
right.
1200s. So, um, but that's not to say there weren't wonderful people there,
Yeah.
and there weren't interesting people doing brilliant work. It's not an indictment of the entire institution and everybody in it. It was just a very, very big vibe shift,
Yeah.
coming from California.
So you went from physics and then you made the shift to climate science.
Yeah, I would argue it's not a huge shift because I still use my physics background every day. I do physics, I just apply the physics to a different system. So instead of looking at the entire universe, I look at the only good part of it, which is Earth. And I don't regret having done a PhD in physics. Like I think that skill set has been really invaluable. And also I'm glad that I learned all this weird stuff about the universe. Um, but I knew when I graduated that this is not what I wanted to do with my life. I didn't exactly know what I wanted to do with my life, but I got this fellowship at Stanford, in the policy school, where they basically said you can work on anything as long as it has a science component and a policy component. And so I kind of flailed around for a little bit before I found earth science, climate science, and I was like, oh man, this is what I've been waiting for. This is the thing that's really, really interesting to me. I can use physics, I can learn about the world, but it's also incredibly relevant, and it kind of has these avenues for being incredibly creative. So my first paper that I ever wrote in climate science was trying to explore this question of, well, could we run out of wind, theoretically? Like if we built too many turbines, and if we put those turbines in the jet stream, could we extract too much wind? So is wind really a renewable resource? And so I got to do this crazy thing where in a climate model, I put turbines all throughout the atmosphere. I had wind turbines floating in the jet stream, sucking up the wind. And the answer is yes, we could run out of wind, if we generated roughly 100,000 times current global power demand. Basically, nothing would happen up until that point. And then you would basically shut off weather. You would change the atmospheric circulation so much that really, really weird things would happen. But this is only going to happen at enormous, kind of unfathomable, um, power generation numbers. It's just not going to happen until up to that. Basically, the what we found is that the limits on wind power are political, they're economic, they're not geophysical.
Right. They also got geographical, right? We don't. There isn't a floating. Are there floating wind turbines in the atmosphere? I haven't
So
heard of.
at the time, this was more than a decade ago. That Google was talking about, hey, maybe we could have wind turbines on kites and we could float them up in the jet stream because we do know that the winds are really steady and persistent there. So at the time, it seemed like a crazy idea, but not necessarily an infeasible idea.
Yeah, yeah, that is fascinating.
Yeah.
But then you move to like climate modeling, right?
Yeah. So I still do work like that. I do a lot of work with climate models, which are basically like little toy digital planets on a computer that you can do horrible things to. Um,
And with these climate projects, because you create projections of global temperatures, and that's particularly important at the moment. But and we see in the news all the time these sort of projections. Scientists project these will be the temperatures in 100 years, and I always think like how accurate are they? Because there are so many factors that you can put into a model, and they can change the temperature massively, and they're very conditional to how humans behave, I suppose.
Yeah, I think that's absolutely true. So I'm really glad you said projections and not predictions.
Yeah.
I'm such a pedant about this, right? Because we don't make predictions because predictions say this will happen. Projections are conditional. They say if we do this, this is what could happen. And you're right that the number one source of uncertainty in global climate projections is what emissions are going to look like, what humans are going to do. We don't know how hot it's going to be at the end of the century because we simply don't know the emissions trajectory. But you are absolutely right that even on top of that, there's a lot of physical uncertainty in the climate system. We've never done this experiment before. Like we've never kicked the Earth system this hard, this fast, and so there's a lot that we don't understand about how the planet responds to that and how those changes can feed back on the warming.
Yeah, okay. So when people look at in the news, they sort of get terrified by these projections, but actually there could be a lot of room for error depending on the sort of parameters you put into the model initially.
Well, not necessarily error, I'd say, but if you look at a world that's 5 degrees Celsius hotter, and you don't like that world, let's not do that. We can't guarantee that we're safe if we drastically cut emissions. We can't guarantee terrible things won't happen, but we do know that the risk of really scary things increases as the temperature does. Our best understanding right now of the Earth system says that if we stop emitting carbon dioxide, the Earth will stop warming. So there's not a lot of warming that we know of kind of waiting for us in the pipeline. That doesn't mean that changes will stop, because the Earth isn't done responding to the emissions that are already in the atmosphere. It takes sea ice, or it takes ice a really really long time to melt. It takes the deep ocean a really long time to get the message. So even if we stop warming tomorrow, we would still see sea level rise. We would still see ocean changes, but we don't have a lot of warming waiting for us in the pipeline, to the best of our knowledge.
Right. So the planet's trying to like find an equilibrium from these changes, and it's still so.
Mhm.
What is the lag time until it finds an equilibrium? I guess.
I mean, it's basically the time scale for the heat to get mixed down in the ocean, which is centuries or even millennia.
Yeah, well, that's scary. Um, but yeah, no, I sometimes think that because people see these projections and get quite terrified, and I'm trying to make a segue into the fact that you've written a book about emotions, and it's called Human Nature: 9 Ways to Feel About Our Changing Planet, and that's going to be released later this year, if I'm right.
Yep.
And this is climate change told through 9 emotions. So, what gave you the premise for that sort of book? Is it making climate change less sciencey and more emotive, I guess?
I think it's to make it about both. I think for me, I was really struggling with, well, I'm a scientist and I think in terms of numbers and equations, but I'm also a human being. And as a human being, I think in terms of the things that I feel. And for a long time, it kind of seemed like to be a scientist, you would have to put your emotions to one side because that's not how you be a good objective scientist. But then I realized that pretending I don't have emotions, that doesn't make me more credible. because I do have emotions. And so in ignoring data and pretending that I am perfectly objective because I am a science robot who doesn't ever feel anything, that's just lying. And so what I want to argue is that there is absolutely room for both, and we need to do both. You can have feelings about the changing planet, and those go hand in hand with the really rigorous science that underpins what we know about how the planet is changing. And so what I was trying to do in the book is it's structured in 9 chapters, 9 different emotions. And in each chapter, there's kind of an emotional centering, and then a scientific concept, and then additional stories brought in to kind of make it a little bit more interesting for folks who don't love equations as much as I do. So, for example, in the guilt chapter, the theme is attribution. Basically, how do we know that it's human activities that are warming the planet? And how should we feel about that? Because you're a geologist, right? Like that there's a lot of stuff that can happen that can make the planet be in a very different state. Plate tectonics, orbital shifts, volcanic eruptions. So how do we know that the changes that we currently observe are due to humans, and not something natural? So in that chapter, I go through and I kind of talk about the things that we know that can change the climate. My favorite story is that in sort of early modern Europe, so the 1300s, 1400s, 1500s, there was a series of large volcanic eruptions, and those made the climate cooler than it would have been otherwise. And at the time, you start seeing a human response to that. You start seeing people starting to say, hey, the weather's weird. My livestock died. My crops are failing. It's her fault. And that's where you start seeing a real spike in witchcraft accusations. Now, can you say, oh, climate change causes people to be burned at the stake as witches? No, absolutely not. But what you can say is that when the climate changes, the human response to it is incredibly complex and really, really hard to predict.
One thing you refer to is in England, we had the Little Ice Ages, and there was a king that then put it into law. Is that right?
Yeah, so there was a king in Scotland, and I apologize for
Which
butchering
king?
your country's history, but you ran out of monarchs in England, I think,
Right.
after I think Elizabeth the First died. So he had to come down and be king of Scotland and England.
Oh, that James the
Um,
First.
James the First, yeah, and he was very interested in witchcraft. It was kind of his hobby. He did experiments. He was really involved in the arrest and sort of interrogation slash torture of some of these accused witches. Very interested in data gathering, real weird guy. And I think he's the only British monarch to have written a scientific paper that's been peer reviewed. He wrote one called The Demonology on identifying and punishing witches. Um,
Who peer reviewed that?
I mean, the scientific community were all like, this is great. We love it, because they knew what would happen to them if they
Yeah.
didn't love what the king wrote. But anyway, when he became king of England, all of the artists and playwrights wanted to kind of get royal favor. So they wanted to suck up to this guy. And William Shakespeare was like, we've got a king from Scotland who really loves witches and is very proud of his ancestry. And so that's where we get Macbeth.
Wow. Yeah, that's great. Yeah, you've gone from drama, so maybe like Shakespeare and Macbeth, then you've gone to theory of relativity, then climate models, then back to Macbeth. Um, yeah, there was also the which I heard somewhere that you say that it's sort of a basis from religion as well, because I learned that climate change has its role in sort of Ragnarok.
Mhm. Yeah, so I mean, I'm obviously obsessed with large volcanic eruptions of the past, um, but there's I think good evidence that the year 536 AD was one of the worst years in human history to be alive. And that year, a big volcano went off. I don't think we know exactly where it was, but we do know that it led to a large climate response. It made conditions, especially in Scandinavia, which was already a marginal place, very unlivable. We think a substantial part of the population starved to death. And then from the sort of wreckage, there kind of arose a new culture, which we think of as the Norse culture, as Vikings. And in the Viking mythology, the world ends at Ragnarok. And Ragnarok happens when the sun goes dim, there's a forever winter, all this terrible stuff happens. And there's an argument to be made that that was sort of cultural remembrance of what had happened in 536. That actually wasn't the only massive consequence of the volcanic eruption. We know that when the earth got colder that year, in Egypt, there started being a real movement of rats. So rats wanted to get inside, they wanted to get away from the cold, and so they were going into granaries, places where grain was being exported. And because of this, people started seeing the development of a new disease. Rats came into contact with each other, they spread fleas, they came into contact with people, and the grain and the rats got exported from Egypt up to the rest of Europe. And that's really the beginning of what we think of as the plague of Justinian, which was the first appearance of bubonic plague in the world.
Wow. I wouldn't have correlated that with climate change. That's kind of incredible. Or volcanic eruptions rather.
Mhm.
Um, yes, and I remember one thing you said was that facts are not what changes people's minds. Stories are what changes people's minds. I think you said that in the I think you said that at the talk you gave at Columbia. Stories like Ragnarok and witchcraft, it's also very emotive, very visceral with regards to fear. I guess I don't know if that's one of the emotions you cover in your book, but fear must be a huge. It fear seems to be a very huge driver for encouraging human behaviors against global warming. Um, I wonder if that's the best driver.
I mean, I don't think so personally. I think there are really scary things. But I personally find that fear is very demotivating for me. I get freaked out. I kind of run around like a chicken with its head cut off. I'm not being my best self. I'm not being my most sort of rational, productive self when I'm gripped by fear. Um, I think the stories of witch hunts and Ragnarok are interesting because they help engage people who don't want to talk about climate change, who are like, oh, you're just going to tell me to, you're a climate scientist, you're going to tell me I'm a bad person, you're going to tell me to not use plastic straws or whatever. I don't want to hear it. And people are interested in things. People want to hear interesting stories. Um, and I think that's a good way in to talk to people. What I try to do in the book, I do talk about fear and grief and guilt and the emotions that we would typically associate with climate change, but I also want to talk about pride. My when I talk about pride, I start out talking about hubris. Like, what if we geoengineered the world? What if we relied on spraying aerosols into the stratosphere to cool it off? That seems very hubristic. But there's also a sense of pride and a job well done. That if we could get this stuff done, if we could cut emissions, if we could do the things that we know we need to do, we could look back and be genuinely proud of ourselves. And I think it's important to talk about this is not an asteroid heading toward us that we're powerless to avert. Like, this is, we know exactly what's causing climate change, so we know exactly how to stop it. And I think talking to people about that and talking about where the emissions are actually coming from can be really empowering.
Sure. Well, that's optimistic, which is not necessarily the case with climate change. Normally, the narrative or the common belief is that it's a climate apocalypse is imminent or too late. You know, Is that true? You know, how do we fight against that narrative, do you think?
I mean, climate change isn't pass fail, right? It's not you get no climate change or you get a disaster. I think the IPCC messaging is right, which is every ton of carbon dioxide matters and every tenth of a degree matters. So everything we can do to limit emissions is really, really going to matter. A lot of times people ask if I'm optimistic or I'm hopeful about climate change. And to me, that's kind of like asking, like, are you optimistic you can clean your room? Like, I don't care. Like, it's a weird question. Like, just clean your room, right? Like,
No.
we know what we have to do, and there's a lot of work that can be done. So just do it. And
Yes.
if being optimistic, if being hopeful helps you do that work, great. But it just seems like such the wrong question for me.
Yeah. You say we need courage, not hope. What, I mean, why is that? Do you think that's such an important distinction?
I mean, I think, hope, we should have hope in an active way, right? Like hope in doing the thing. And sometimes, especially now, it takes bravery to do the right thing. It takes bravery to face the consequences of what's already happened, but also courage to say, we're going to write the ending of this story ourselves. I think that's really important to hold on to. I don't want this message of we need courage, not hope, to be there's nothing we can do and we just need to be brave enough to face the apocalypse that's coming, because that's not it. I think, bad things are happening. We have baked in climate change. We have emitted, 1.5 trillion of carbon dioxide. That is up in the atmosphere. That's changing things. But at the same time, like the future is very much still in our hands. Going back to what we were talking about before, the number one determinant of what the climate's going to look like in the future is what we're going to do.
You wrote, "Courage is the resolve to do well without the assurance of a happy ending," which I thought was which was brilliant. I thought um, there are positive emotions that you've put into the book, which I really like courage, and one of them was pride, and one of them was love, and that is, I suppose, is that a love for the planet that we live on?
Yeah, I think so. I mean, it's such a cliche to say, oh,
Mhm.
yeah, man, everything's connected. And it's a cliche, but it's true.
Yeah.
It's really, when you start studying this planet, like I'm sure you've encountered this, right? Like everything is connected in this incredible, beautiful way. I've met a couple astronauts in my life, and when you talk to astronauts, they are profoundly changed by having seen that blue marble from space, from looking down and seeing the planet that all of us live on, and how beautiful it is, and how fragile, but also how resilient. And what I was trying to talk about when I talked about love is how do we negotiate our relationship with this place? How do we negotiate being human in nature? Like, are we part of it? Are we separate from it? Does it matter? And the way I think about it is we always need to be thinking about and strengthening our bonds and reevaluating our relationship with the world, because that's what you have to do in every relationship that lasts. And for me, I feel profoundly grateful to be here, to be on the only good planet. Even if we did all go to Mars, like we would still be tied to Mars, this sort of like inferior planet, by the laws of physics, by science. We can't escape those. And so once you really start looking into how interconnected this place is and how interconnected we are with each other, it's just a very beautiful, kind of overwhelming feeling, I think.
I agree. Yeah, and your book is out, Human Nature: 9 Ways to Feel About Our Changing Planet, and that's out in June. Is that right? So June 17th on Amazon is when I
Hmm.
went to pre-order it, and I can't wait
Yeah.
to read it. To be honest, I'm
Thank you
really
so much.
excited. Kate Marvel, thank you so much for coming on the Core of Everything. I really appreciate it.
Thank you for having me. It's been fun.
Thank you.